The least glamorous part of my entire setup is the part one would genuinely cry without. Not the AI tools, not the automation, not the video pipeline I spent months building, the backups. I almost never talk about them, and I almost never have to think about them, because the whole point is that they just run. But I want to walk you through exactly how I built this system, why it is structured the way it is, and the very specific and limited role AI actually plays in keeping it honest. Because there is a right way to use AI in a backup system and a wrong way, and the wrong way is one hard drive failure away from a very bad day. Why this is the thing everyone skips. I understand why people skip backups. They are not exciting. They do not make your machine faster, or your videos better, or your workflow more impressive to show someone. They sit in the background doing nothing visible until the day they are the only thing standing between you and losing everything. And that is exactly the problem. The cost of not having them is invisible right up until it is catastrophic. I have been around long enough to see what happens when someone loses a drive with no backups. Years of photos, a business that cannot invoice because the accounting files are gone. A project someone spent 6 months on that simply ceases to exist. It is not dramatic in the way a house fire is dramatic. It is worse because it is quiet and total and there is nothing to do about it after the fact. You can replace hardware, you cannot replace the data that was on it. So before anything else, I want you to take this seriously because I am going to give you a real system and not just a vague suggestion to back things up sometime. The 3-2-1 idea. The frame I use is called 3-2-1. 3 copies of your data on 2 different kinds of storage media, with 1 copy stored offsite. 3 copies means you need 2 drives to fail at exactly the same time to lose your data, which is very unlikely. 2 kinds of media means if there is a bug or a failure mode that affects one type of storage, you are not completely exposed. 1 offsite copy means if something physical happens to your location, a flood, a theft, a fire, your data survives somewhere else. This is not a new idea. It is old and boring and it works. I did not invent it and I am not going to dress it up. It is 3-2-1, and once you have internalized the frame, building a real system around it is mostly just filling in the boxes. What my 3 copies actually look like. My 3 copies are structured like this. The first copy is my working data, the files on my main machine that I am actually using. The second copy is a local backup drive, a separate physical drive sitting next to my machine. The third copy is an encrypted remote backup sent to cloud storage automatically. The local backup gets me back up fast if my main drive dies, because I do not have to wait for a download. The remote backup gets me back up at all if something happens to my physical location or both local drives somehow fail at once. The important thing is that all 3 are real copies that I could actually restore from. A copy you cannot restore from is not a copy. It is a file that looks like a copy until the day you need it. Everything is encrypted. I want to be clear about this one. The remote copy is encrypted before it leaves my machine. That means even the service storing it cannot read what is in it. The encryption key lives with me, nowhere else. This matters for a couple of reasons. 1. It means my data is private by default regardless of what happens on the storage provider's end. 2. It means I have to be very careful with that key because if I lose it, I cannot restore. I keep the key backed up separately in more than one place and I treat it like a password for something that would ruin my life to lose. If you are building this kind of system yourself and you are going to encrypt, do not skip the step of backing up the key. I have seen people set up encrypted backups, lose the key, and discover that their backup is perfectly intact and completely unreadable. Schedules, so I never have to remember. Everything runs on a schedule. The local backup runs nightly. The remote backup runs nightly on a slightly offset time, so they are not hammering resources at the same moment. I do not have to remember to run them. I do not have to open anything. I do not have to check a box. The schedule runs whether I am at my machine or not, whether I am busy or sick or traveling or just forgot. This is the whole point of automating it. A backup system that depends on me remembering is not a reliable backup system. It is a backup system that works most of the time, which is very different from one that works all of the time. Most of the time is not a backup strategy. All of the time is the tools doing the actual copying. The actual copying is done by tools that are not AI. They are old, boring, reliable pieces of software that have been doing this specific job for years. One of them is rclone, which handles the remote sync. The other is a straightforward local backup tool that copies files to the second drive. These tools do not improvise. They do not make judgment calls. They do not hallucinate a file name or decide that a folder looks unimportant and skip it. They copy exactly what I tell them to copy, to exactly where I tell them to copy it, every single time, with the same result. That predictability is the whole feature. I am going to come back to this point when I talk about AI, because this is where the line has to be drawn clearly. John 22:20, where AI actually helps. Now I want to be honest about where a little AI genuinely earns its place in this system, because it does help, just not in the way you might expect. The first place is writing the scripts and config files faster. When I was first setting up rclone flags and writing the scheduled task configurations, having a model helped me get the syntax right and check my logic saved me real time. I would describe what I wanted and it would draft something close. I would read it carefully and adjust, and I ended up with a cleaner config in an afternoon instead of a day of documentation spelunking. The model helped me write the tools faster. It did not replace the tools. AI for log summaries in plain language. The second place AI helps is summarizing the backup logs. Crancone and most backup tools produce logs after each run. Those logs can be long and full of technical lines that tell you a lot if you know how to read them, but not much if you are glancing at them quickly at the end of the day. I have a small step in my setup that feeds the relevant log output to a model and asks it to summarize what happened in plain language. Did everything complete successfully? Were there any files that failed to transfer? How much data moved? Anything unusual? It comes back to me as a few readable sentences instead of a wall of output. I still keep the full log. The summary does not replace the log, but it means I can spot a problem in 10 seconds instead of reading through hundreds of lines. AI for plain language failure alerts. The third place AI helps is turning failure alerts into something I actually understand at a glance. When a backup fails or runs longer than expected, I get an alert. And because the alert has been passed through a model first, it is not a raw error code. It is a sentence that says something like, "The nightly remote backup did not complete last night. The last successful run was 2 days ago. The error looks like a network timeout. Here is the step that failed." I can read that in the middle of doing something else and immediately know whether I need to drop what I am doing or whether it is a minor hiccup that will self-correct. Plain language is genuinely useful when your goal is to act on information fast. What AI must not do in this system. Here is where I have to be very direct, and it is the most important part of this whole video. AI must not be the thing doing the actual copying, full stop. I want you to think about what a language model actually is. It is a system that predicts plausible next steps based on patterns. That is extraordinarily useful for a lot of things. It is not what you want running the process that determines whether your data exists tomorrow. Backup software needs to be deterministic. It needs to do the same thing every time. It needs to not have an off day or a bad context window or a moment where it decides the right move is to skip a folder because the prompt was slightly ambiguous. I have seen people build setups where they let an AI agent decide what to backup or let a model write and execute the backup commands dynamically at runtime. That is a reliability disaster waiting to happen. The boring, dumb, reliable tool is not boring and dumb in a bad way. It is boring and dumb in the best possible way. It does what it does every time with no creativity involved. That is exactly what you want. Keep the AI at the edge, not the core. The mental model I use is this. AI lives at the edges of my backup system. It helps me build the system. It helps me read the output of the system. It helps me act on alerts from the system. It does not touch the core of the system, which is the actual data movement. The core is handled by software that has no opinions, no inference, and no ability to improvise. Everything in between those two things, the setup and the reading and the alerting, that is where AI is genuinely useful and genuinely safe to use. The moment you let it into the core, you have introduced unpredictability into the one part of your infrastructure that needs to be predictable above everything else. The rule I never break: test your restores. There is one rule I hold to no matter what, and it is the rule I see people skip more than any other. You have to test your restores. A backup you have never actually restored from is not a backup. It is a set of files that you hope are restorable. There is a real difference. I do a test restore on a schedule where I actually pull files back from the backup and verify they are what I expect. Not all the files, not the full system, but a meaningful sample. And I have caught problems this way that I would never have caught otherwise. A backup that was running fine on the surface but had a permissions issue that meant the restored files were not readable. A remote backup where the encryption key I thought I had backed up was an older version and would not have decrypted correctly. Both of those would have been catastrophic if I discovered them on the day I actually needed the backup. I discovered them on a quiet Tuesday when I had time to fix them. Test your restores, run them on a schedule. Treat the restore test as part of the backup system, not an optional bonus step. The honest bottom line, here is the honest bottom line on unglamorous infrastructure. Nobody is going to give you a like or a follow because your backup system is solid. It will not show up in any demo. Nobody will see it running. And you will spend real time setting it up properly, running the cables and configuring the tools and testing the restores and making sure the encryption keys are safe. And then nothing will happen because nothing will go wrong, and you will never know what it saved you from. That is the whole point. The payoff is invisible until the one day it is not. On that day, you will not care how boring the tool was. You will not care that nobody saw it. You will just be very glad you built it. The most reliable part of my setup is the part nobody ever asks about. I think about that every time I am tempted to spend time on something flashier instead. If you want to see more honest breakdowns of how I actually run my setup, the boring parts and the useful parts, and where AI fits and where it does not, subscribe and follow along. Thanks for watching, and I will see you in the next one.